Hi there, Terrence Parr here, one of your faculty in the data science program. In this introductory video, I'd like to introduce you to your Mac hardware and some of the key software elements, at least the ones that you'll be dealing with in the data science program. Until now, you've most likely cared more about browsing speed, YouTube videos, that sort of thing. But in the data science world, we're very concerned with the amount of information that we can process. So first, let me show you about your operating system here. So if you look at the About box on your Mac, you'll see that it'll pull up a small little thing here that will tell you about the key elements. So the first thing you notice is that I've got a 4 gigahertz quad-core processor. What does that mean? The 4 gigahertz relates to the processor speed. And all that really means is that 4 billion times a second, it can effectively process an instruction. It's not quite that simple, but let's call it 4 billion instructions a second. Quad-core means there are 4 effective copies of the processor, and so it can do 4 things in parallel. It's actually more complicated than that, of course, but you can do at least 4 things in parallel. All right, so the memory size, 32 gigabytes. That's 32 billion bytes. A byte can hold a small number between 0 and 255. So that means it can hold an English character. So that can be 32 billion English characters. That's a lot. If you had objects that were 32 bytes long, you could hold 1 billion of those. That's quite a bit of memory. And of course, the operating system takes part of that. The reason we care about memory is that it dictates how much you can process at one time. It's kind of like your short-term memory. And this is the memory that disappears when you turn off your machine. So if you can't process it in memory, it's going to be much harder. You have to process pieces of it, pulling it in from the disk, which we'll talk about next. If it doesn't even fit on your disk, then you have to have multiple computers, and your problem is even harder. All right, let's look at the disk storage. Notice I've got 2 disks here. My main disk is flash storage, that's SSD. That means it's not a spinning disk. We don't really use those anymore. So these drives hold data that does not disappear when you turn the power off. But it is much slower than the memory in what we call RAM. So this is 1 terabyte, so that's 1 trillion bytes. That's a lot of bytes. Notice I've got this backup drive here. What this is doing is every hour, Time Machine wakes up and takes a snapshot of my drive, does a difference. So one of my key rules is always make backups. Every year somebody gets their laptop stolen, or it catches on fire, or they spill coffee in it. And we'll be very sympathetic, but you have been warned. You need to make backups. So one of the things you can do is use Backblaze. This is what I use for off-site storage. It's pretty cheap. I don't know, like $100 a year. Oh yeah, here we go. $6 a month. So what it does is the same thing. It wakes up and there's a little background process that constantly is copying stuff away from your machine off-site. So if your machine gets stolen, you've got it. Okay, so let me say something about this Amd Radeon chip here. This is the graphics processor. You've probably heard of a GPU. That is a graphics processor that does lots of little small operations in parallel. It was originally designed for games, but of course now we use it for deep learning neural net machines. So unfortunately, the AMD chip does not run the necessary software for us to do it, to use deep learning with PyTorch and TensorFlow and all this, but that's okay. We have access to them at Amazon and so on. So you're not going to be running PyTorch on your local machine except as running it on the main CPU. Okay, so your main channel for communication with the faculty and staff is Slack. So you will be getting an account, and you can see we've got all these Slack channels and where we do communication and that sort of stuff. There was going to be one for every class, and of course there'll be other ones random, and a cat channel so you can show off your cats and things like that. You're probably also familiar with Zoom already, but this is where we're going to be doing live labs, lectures, office hours. It's very easy for us to communicate this way. So we will be setting this up, and you will have access to our Slack or our Zoom channels. Okay, so let me introduce you to the terminal. So this program here is sort of the low-level means by which we communicate with a machine. Let me bring up a little folder for you here, or a finder. This is an interpreter just like Python. Instead of typing Python commands, I type commands into what we call the shell or the terminal. So for example, I can ask it, print working directory, where am I? And it tells me where I'm at. And that corresponds to this folder right here. And if I want, I can jump into, say, the notes folder, and I can use ls to indicate, or to say list all the files. And that is a list of all the stuff you see here. You got alert.js.html and so on. So the cd command is how I move around. I can move back and say ls, and now notice it's got these files here. I can ask what processes are running on the machine, and I've got a whole bunch of stuff running in other shells. There's a lot more details you can get there. A more visually interesting version of that is this thing called the activity monitor. And here you'll see that all the processes I have running and what percent of the CPU. You can see I'm recording the screen right here. Who's using all the memory, what kind of network traffic is going on. So very useful if you've got a bunch of, if your machine seems slow, you can look at this to figure out, okay, who's running, who's taking all my processing time. So in the old days, this terminal was all we had. We didn't have GUIs. Back before 1984, this is what we saw, just this little window right here. And we did everything in it. For example, if I want to look at that README file, I can say VI, for it's an editor. You guys probably know it as Vim today. And this allows me to move around old school. And I can look through the file and I can make changes and I can get out. By the way, if you get stuck in there, the way you get out is :Q and exclamation mark, which we say is bang. So :Q bang to get out without writing anything. Okay, so one of the reasons we need to know this shell is because we're going to use it to communicate with a remote machine. So for example, I can communicate, or I can launch a connection to one of the machines in the computer science department. And now notice that my machine name has changed and I'm on a totally different machine. If I say ls, oh, all kinds of weird files. So you can see that I'm in a totally different directory and I'm actually giving commands to a totally remote machine. And this is important when you launch machines at Amazon. You're going to create servers for me and submit your homework that way. So when you need to create a deployed server, nobody deploys your software from your laptop. They do it at some, for a server. Okay, we get out of that machine. Obviously, executing Python is important, and I'm going to do that in a separate video. It talks all about the installation of Python. So just keep in mind that you're going to be using your machine very differently than you normally would. It's all going to be about processing data. So that means we need to know about processors and RAM and disks, and of course, then the software that does all the work. Okay, goodbye.